Hello everyone, this is Nandini Joshi from MTech IT 2K20 batch, and this video is also a part of my assignment based on the subject analysis and design of algorithms. This is the second part of the video which was made previously and continues the second internal assignment question paper. This is the set B of that same paper. So here we were asked some fill in the blank questions. The first question is dash is the process of finding the solution to a problem step by step. So the correct answer to this question is iteration. Iteration is the process of finding the solution to a problem step by step. In the process of iteration, we repeat the same problem, that is, we follow a certain number of steps, we repeat and then we repeat the same process in a loop until we find the final solution. So that is the process of iteration. The question number 2 is the time complexity of an algorithm is denoted by. So the correct answer is big O notation. Big O notation, or the order of any notation. So time complexity can be denoted by big O notation. Question number 3, dash is an example of a dynamic programming problem. So here in this blank we can write any dynamic programming problem. The correct answer can be any problem which is easily solved through the dynamic programming approach. So the possible solutions to this question can be the LCS problem, that is the longest common subsequence, or the matrix chain multiplication problem, which is also a correct answer to this question. Question number 4. In the dash approach, a problem is divided into smaller subproblems and solved recursively. By reading the description, we can easily suggest the name of the problem, that is divide and conquer approach. That is, we divide the whole problem into some smaller subproblems and then use recursion to solve the problem, to solve the separate subproblems and then combine into the final solution. The fifth question is the dash algorithm finds the shortest path between two nodes in a graph. So the shortest path can be found using the Dijkstra's algorithm, and this algorithm uses the greedy approach by finding the minimum path from the present node and then moving forward on the minimum path node. The question number 6 is the dash algorithm is used to traverse a graph in a depth first manner. So the correct answer is depth first search, in which traversal is done using a depth first manner, and it is similar to the next question in which the breadth first search algorithm is used to traverse a graph in the breadth first manner. These are two similar questions. Question number 8 is the time complexity of binary search algorithm is. So the time complexity can be order of log n, that is big O of log n. Question number 9, the time complexity of merge sort algorithm. So the time complexity of merge sort algorithm is, as we know, that order of n log n. Any sorting algorithm has the time complexity of order of log n, and n is combined with log n as to traverse through the whole array and then sorting each element of the array by visiting each element. So any sorting algorithm can easily have a time complexity of order of n log n, and any search algorithm can have a time complexity of order of log n. Question number 10. The time complexity of quicksort is, it is similar to the previous question, and as quicksort is also a type of sorting algorithm like merge sort, but quicksort has two different cases, that is, its time complexity is different in the average and best case, and its time complexity is different in the worst case. So here, as no case is specified, we will be writing the best case time complexity, which is order of n log n. If we had been asked the time complexity of quicksort algorithm in the worst case, then our answer would be order of n square. Question number 11. In the dash algorithm, two input sequence is divided into two parts and the search is continued in a part where the key may be found. As we know by the name or the description of the algorithm, that dividing a problem into two parts, that is dividing a problem into binary parts and searching for an element, it is similar to the binary search algorithm. So here the correct answer is binary search. Question number 12. Dash is a type of algorithm that always selects the best possible choice at each step. The best possible choice at each step can be chosen to find the minimum cost or the minimum distance and to maximize the profit of any algorithm or for any problem. So that is a type of greedy technique which we use to minimize our cost and to maximize our profit. So the correct answer for this question number 12 is greedy technique. Question number 13. Dash is a coding technique used to compress data without losing any information. So that the correct answer for this question is Huffman coding. Huffman coding approach or the technique can easily compress data, that is reduce its size, its total number of bits without losing any type of information. It is also a type of greedy technique in which we minimize the number of bits, that is we reduce the size of the whole file. Question number 14. Dash is an algorithm that finds the minimum weight spanning tree of a graph. So the minimum weight spanning tree of a graph can be easily said by the name of the algorithm, that is minimum spanning tree. Question number 15. The time complexity of Huffman coding algorithm is, so the Huffman coding algorithm's time complexity is order of n log n. So the correct answer here is order of n log n. Question number 16. The time complexity of the minimum spanning tree algorithm is, so the time complexity of minimum spanning tree algorithm is order of m log n or order of n log n, that is similar only. So the correct answer here is order of m log n. The time complexity of the longest common subsequence problem is, longest common subsequence problem, the time complexity is order of mn. Order of mn or order of n square, where m can be considered as the length of the first sequence and n can be considered as the length of the second sequence, that is number of characters present in the first and second sequence are represented each using m and n respectively. If both the sequences consists n number of codes or n number of letters, then the time complexity can be order of n square. So here the correct answer is big O or order of mn. Question 18. The time complexity of the matrix chain multiplication problem is, so the matrix chain multiplication problem is a type of dynamic programming approach, that is it is solved using dynamic programming approach and its time complexity can be order of n cube, order of n to the power 3. Question number 19. The notation used to describe the upper bound on the running time of an algorithm is, the upper bound or the tight upper bound can be described using the big O notation. So the correct answer for this question is big O notation. Question number 20. The notation used to describe the lower bound on the running time of an algorithm is, so here the correct answer is omega notation. So in this way we have answered all the fill in the blanks question, and now we will be moving on to the match the column section. Here the same option can be matched with any two number of questions, or any two number of questions can be matched with multiple number of options. So we will be seeing the correct answers for all of these questions. The first one is binary search. So binary search can easily be matched with divide and conquer algorithm, that is B. Divide and conquer algorithm, or the approach is used in binary search by dividing the whole problem or by dividing the whole array into two equal parts and then searching for the element in that sub array which consists the element. So the second is depth first search. The correct option can be a graph algorithm, and it is similar to the question number third, that is breadth first search. So the depth first search and the breadth first search both are types of graph algorithm. So both will be matched to option E, that is graph algorithm. Question number 4, merge sort algorithm. Merge sort algorithm is also a divide and conquer approach. That is, it also uses the same approach as binary search algorithm. By merge sort divides the array into into arrays of individual elements and then uses the technique for sorting and then merges the whole array into the combined sorted array. So question number 4 can be easily matched with divide and conquer approach. Question number 5th, quick sort. Quick sort algorithm is also a type of divide and conquer approach. Question number 6th, Huffman coding. Huffman coding can be matched with two different options. Here we can see option number A, greedy algorithm, and option number F, that is compression technique. So Huffman coding, as we all know, that it is a technique used to compress the size of a file without reducing the data or without losing any data. So it is a compression technique, and this technique uses greedy approach by selecting the minimum number of bytes for each problem or for each code. So it can be matched with option A, greedy algorithm, and option F, compression technique. Question number 7th, minimum spanning tree algorithm. This is a type of greedy algorithm, so it will match with option number A. Question 8, upper bound on running time. Upper bound on running time gives the time complexity of any algorithm. Upper bound on running time is the big O notation or the order of notation. So this is used to represent the time complexity, that is option G is the correct option. Question number 9, longest common subsequence. Longest common subsequence is a type of dynamic programming problem. So it will correctly match with option number C, that is dynamic programming problem. Option D, big O notation. Big O notation is a type of, here it is written that algorithmic notation or asymptotic notation, both are the same. So question number 10th will be matched easily with option D, that is asymptotic or algorithmic notation. Big O is a type of algorithmic notation. So we have also answered all the match the following questions and as well as the fill in the blanks question. This completes the second internal assessment. Thank you everyone.